On a quiet night in a radio observatory tucked into the hills of Northern California, a wall of receivers pointed at a tiny, fast-moving speck of light racing through our solar system, and for 7 straight hours scientists listened. What they were hoping not to hear was almost more interesting than what they were hoping to hear, because this object had already broken every rule in the book, and nobody could fully explain why. This is the story of 3I Atlas, the strange visitor from another star system that forced some of the world's most respected scientists to stop, turn their instruments toward it, and ask a question they don't ask lightly. Could this thing be sending us a signal? It all began on July 1st, 2025, when a survey telescope in Rio Hurtado, Chile, part of a network called the Asteroid Terrestrial Impact, Last Alert System, or ATLAS, picked up a faint object moving in a way that immediately caught astronomers' attention. Most asteroids and comets in our solar system travel in loops, bound forever by the sun's gravity, tracing the same orbits over and over for millions of years. This object was different. Its path was hyperbolic, meaning it wasn't looping around the sun at all. It was simply passing through, on a one-way trip from somewhere else entirely, and it would never return. Astronomers quickly realized this was only the 3rd time in recorded history that humanity had ever detected an object from outside our solar system. The first was the strange cigar-shaped Oumuamua in 2017, which tumbled through our neighborhood so fast and so unexpectedly that scientists barely had time to study it before it vanished into the dark. The second was Comet Borisov in 2019, a more conventional icy visitor that behaved mostly like the comets we already knew. Then came this new object, officially named 3I Atlas, the 3rd confirmed interstellar object ever observed. And almost immediately, it started behaving strangely enough that even cautious scientists began raising their eyebrows. For starters, its size and speed alone made it remarkable. Estimates suggested a nucleus that could be enormous compared to its interstellar predecessors. And it was moving at a blistering pace, fast enough that some researchers calculated it may have originated from a part of our galaxy far older than our own sun. That alone made it a scientific treasure, a genuine piece of another solar system delivered right into our cosmic backyard. But then, the anomalies started piling up. As 3I Atlas approached the sun through the second half of 2025, telescopes on the ground and in space kept watching, and the picture that emerged was not a simple one. The Hubble Space Telescope captured images showing a glow ahead of the object, in the direction it was traveling, rather than the classic tail trailing behind it that we associate with comets. That's backwards from what decades of comet science would predict. Spectroscopic measurements, the kind that break light down into its component wavelengths to identify chemical fingerprints, initially showed little to no obvious gas surrounding the object, even though comets are supposed to release gas as they warm up near the sun. Then, as 3I Atlas closed in on its perihelion, its closest approach to the sun, on October 29, 2025, something even stranger happened. NASA's Jet Propulsion Laboratory tracked the object's motion with extreme precision and found that it was accelerating in a way that couldn't be explained by gravity alone. Scientists call this non-gravitational acceleration, and it usually happens when a comet is venting gas and dust so violently that the escaping material acts like a tiny rocket thruster, nudging the object off its purely gravitational path. The trouble is, the amount of acceleration measured on 3I Atlas would have required it to lose somewhere around 10 to 13% of its total mass. And yet early images suggested the nucleus remained intact, with no sign of the object breaking apart the way you'd expect from that kind of violent, sudden mass loss. That detail is exactly what caught the attention of Avi Loeb, a well-known Harvard astrophysicist who has built a reputation for taking interstellar anomalies seriously, sometimes controversially so. Loeb pointed out that the unexplained acceleration, combined with the object's forward-facing glow and its unusual color, which some observations suggested was bluer than sunlight itself rather than the redder tint typical of dusty comets, opened the door to a far more provocative explanation. He suggested that if the acceleration wasn't caused by natural outgassing, it might instead be what he called a technological signature, the kind of thing you'd expect from an internal engine or propulsion system, rather than a chunk of ancient interstellar ice. To be clear, Loeb never claimed with certainty that 3I Atlas was an alien spacecraft. What he did was lay out a list of anomalies, ranked by likelihood, and argue that science should investigate rather than dismiss unusual data just because it's uncomfortable or doesn't fit a tidy explanation. He pointed to the object's tightly focused jets, which appeared to stay pointed in a consistent direction across 1,000,000 kilometers of travel despite the object's rotation, something you don't typically see from a tumbling natural chunk of rock and ice. He also highlighted a strange coincidence in the object's projected path. noting that its flyby distance from Jupiter in March 2026 would land remarkably close to a specific gravitational boundary called Jupiter's Hill radius, a coincidence he calculated as extraordinarily unlikely to happen by chance. Naturally, this is where things got loud. Loeb's posts on the subject spread rapidly across social media, tech blogs, and mainstream news outlets, with headlines asking whether humanity might have just detected its first alien probe. Other scientists pushed back hard, arguing that non-gravitational acceleration is not actually that unusual in comets, and that the measurement uncertainty on 3I Atlas's motion was large enough that the anomaly might not be statistically significant at all. Critics also noted that losing 10 or more % of a comet's mass through outgassing isn't as extreme as it sounds, since interstellar comets, having never been baked by repeated trips near a star, could easily contain far more volatile ice than the comets we're used to studying in our own solar system. Still, the debate was enough to make the scientific community sit up and take real notice, which is exactly why, once 3I Atlas reemerged from behind the Sun in December 2025 after its solar conjunction, researchers pointed some of the most sensitive instruments on Earth directly at it. That is where the actual signal comes in. Radio astronomers detected faint emissions, consistent with water, or more precisely with its ultraviolet echo known as hydroxyl, or OH, coming from the object, even though it was still nearly 3 times farther from the Sun than Earth is, a distance where comets in our own solar system are usually far too cold to be releasing much water at all. One physicist described it almost poetically, saying that detecting water from an interstellar comet is like reading a note from another planetary system. Proof that the raw ingredients for life's chemistry aren't unique to our own solar neighborhood. That radio detection alone would have been a headline on its own, a genuine scientific first, but it also reignited the bigger question hanging over the entire story. Because if 3I Atlas was going to be caught transmitting anything, radio was the place to look for it. So the SETI Institute, the organization most famous for scanning the skies for signs of alien intelligence, decided to take the anomaly seriously and actually check. Using the Allen Telescope Array, a 42-dish radio interferometer at the Hat Creek Radio Observatory, a dedicated team pointed their instruments at 3I Atlas and began listening across a huge range of frequencies, from 50 Hz all the way up into the tens of megahertz range, specifically hunting for narrowband signals, the kind of tightly focused radio transmission that nature almost never produces on its own, but that artificial technology often does. For more than 7 hours, the array listened. This wasn't a rushed symbolic gesture either. The observations reportedly began less than a day after the object was first announced, showing just how quickly the scientific community was able to mobilize once the anomalies started drawing attention. NASA even got involved on a separate front, with plans for its Juno spacecraft, already out near Jupiter, to use its own onboard antenna to listen for any radio signal from 3I Atlas during its close flyby of the gas giant in March 2026, adding yet another layer of scrutiny to an object that had already become one of the most closely watched visitors in the history of astronomy. So, after all that listening, all that anticipation, and all that public speculation, what did they actually find? The results, published in June 2026 in the Astronomical Journal by researchers, including Sophia Sheikh and her team, were clear and, in a way, almost anticlimactic. No credible technosignatures were detected. The scans picked up plenty of noise, mostly identified as ordinary human-made radio interference from our own crowded airwaves here on Earth, but nothing that could be confidently attributed to an artificial signal coming from 3I Atlas itself. In plain terms, whatever had caused that strange acceleration and that unusual glow, it wasn't broadcasting anything back at us, at least not on the frequencies scientists were able to check. For some, that result closed the book, further reinforcing what most planetary scientists suspected all along, that 3I Atlas is almost certainly a natural interstellar comet, just an unusually large, unusually active, and unusually old one, carrying pristine ice from a star system that may have formed billions of years before our own sun even ignited. For others, especially those who followed Loeb's arguments closely, the absence of a signal wasn't necessarily the end of the mystery, since a natural object could still exhibit some of the anomalies observed without needing an alien explanation at all, and an artificial object wouldn't necessarily be broadcasting anything intentionally either. What's genuinely remarkable, regardless of which side of that debate you land on, is just how seriously the scientific establishment treated this object from the very beginning. This wasn't a fringe conspiracy theory chased by amateurs. This was Harvard astrophysicists, NASA engineers, the James Webb Space Telescope, the Hubble Space Telescope, the Sphere-X Observatory, and the SETI Institute, all turning their attention toward a single fast-moving speck of interstellar ice, precisely because the data kept refusing to behave the way everyone expected. Even the Lucy spacecraft, on its way to study asteroids near Jupiter, managed to catch a distant glimpse of 3I Atlas from over 200 million miles away, just to add one more data point to the pile. And that, in many ways, is the real story here, not necessarily that we found an alien spacecraft, because the evidence increasingly points against that, but that an object born around a star we've never seen, shaped by chemistry from a corner of the galaxy we'll never visit, drifted directly through our solar system and briefly became the most scrutinized piece of rock and ice in modern astronomical history. It reminded everyone, scientists and casual space fans alike, just how much can still surprise us out there and how quickly the entire scientific world can mobilize the moment something doesn't add up. 3I Atlas is still moving, still being tracked, and still expected to pass remarkably close to Jupiter in March of 2026, giving Juno one more chance to listen in before this ancient visitor slips back out into the interstellar dark forever, never to return to our solar system again. Whatever it truly is, a dust-rich fossil from another star system or simply an unusually dramatic comet, it has already done something no object has done in years. It made us look up, question our assumptions, and genuinely investigate the possibility that we are not alone. It's worth pausing on just how much instrumentation was actually thrown at this single object, because it says a lot about how seriously the space community treated the mystery. The James Webb Space Telescope, arguably the most powerful observatory humanity has ever built, was redirected to study 3I Atlas with its near-infrared spectrograph, capturing a detailed chemical fingerprint of the object as it moved away from the Sun in December 2025. Those readings gave scientists clues about the comet's ancient origin, suggesting it may have formed in a much colder, much older environment than anything in our own solar system, possibly billions of years before our Sun even existed. That alone makes 3I Atlas one of the oldest physical objects humans have ever directly studied up close. Meanwhile, the Sphere-X Observatory, a newer NASA mission designed to map the sky in infrared light, spent about a week collecting its own data on the object, adding another layer of chemical detail to the growing picture. Even spacecraft that weren't built for this kind of work got pulled into the effort. The Psyche spacecraft, on its way to study a metal-rich asteroid, managed to capture 4 separate observations of 3I Atlas over an 8-hour window, simply because it happened to be in a useful position. The Stereo mission, originally designed to study the Sun, contributed colorized, stacked images that helped track the object's brightness over time. It's rare for so many unrelated missions to end up focused on the same fast-moving target, and that alone tells you how unusual this situation really was. As for where this leaves us now, the consensus among the vast majority of astronomers remains firmly on the side of a natural explanation. Sophia Chase and her colleagues at the SETI Institute framed their null result not as a disappointment, but as proof that our detection systems actually work, meaning that if there ever is a genuine artificial signal from a future interstellar visitor, we now have real confidence our instruments could catch it. As one astronomer from the Breakthrough Listen initiative put it, the value of this search wasn't just what it found on 3I Atlas, but proving that rapid response techno-signature hunting is realistic with today's technology. So, while 3I Atlas almost certainly isn't broadcasting a message to us, the fact that scientists organized a coordinated instrument cross-agency investigation within days of spotting an anomaly is genuinely remarkable on its own. It shows a level of readiness that didn't exist a decade ago, and sets a precedent for how the next interstellar object will be studied, even faster and even more thoroughly. If stories like this make you want to keep exploring the stranger corners of our universe, make sure you like this video and subscribe, because there is a lot more of the unexplained still out there waiting to be uncovered. Until then, 3I Atlas continues its silent journey outward, carrying its secrets with it. A reminder that sometimes the most profound mysteries in science aren't solved with a dramatic discovery, but with the quiet, careful process of scientists refusing to look away until they've checked everything they possibly can.